Good evening. We're going to see about an DT based lecture video on finite element analysis. So how it is connected with a subject. So we have to design a component part. So then what is the measures widely to perform FEA to reducing the need of physical testing, saving cost and improving product safety and design safety. Before we are going to manufacture produce one component, we are going to test through ANSYS. So it will give an exact report, static or dynamic or thermal, whatever test we are going to choose, that report will generate through the software itself. So finite element is a numerical method used to predict how a component or the structure behaves under real world conditions such as load, heat, vibration and pressure. So in FEA, a complex geometry is divided into small elements, that is mesh, and the mathematical equations are solved as each component to obtain accurate result. Now we are going to see an empathize and define part. Harshan will explain that.
Step 1. Empathize understanding the engineering. We are going to see an empathize. Empathize understanding the engineering problem. In this stage, we focus on understanding the real problem. What is component is failing, where the stress and the deformation or heat affect.
What are the operating conditions and the operations expectations? So empathize அப்படிங்கிறது என்னன்னா existing இருக்க problem வந்து we are not supposed to follow the same. We give an exact new solution for the existing cause and effect. So what is the definition for this FEA? What solution defined?
Where the stress and deformation or heat affect performance, and what is our operating condition and user expectation.
Define.
Problem definition of FEA. Here we clearly define the analysis objective. It is a structural and thermal model or factive analysis. What load constraint and boundary condition act on a component. What material behave and its expected. Analysis the step decider. Analysis a type of selection. Material properties. Load and boundary condition steps.
So a weld it leads to give an accurate and meaningful results by using finite element analysis. So there is a computation fluid dynamics is that it is only for piping industry. So for the other structures like this table or chair, before in the earlier stages they want to bother about the stress concentration factor model. But nowadays we are going to give a major safety about the factor of safety, because the customer satisfaction and customer's fulfillment is best for us. So customer is our loss. So we are going to give a better product. So for this, ideate is the best strategy. We are choosing to give an appropriate answer. So now we are going to see about ideate.
Ideate at this stage we plan the simulation strategy, simplifying geometry without losing accuracy, selection appropriate element types, deciding mesh size and refinement zone. Design alternative can also be compared here. For example, changing thickness, feldet and material and predict the performing using ANSYS before manufacturing.
So ANSYS workbench is used practically. Geometry is importer or creator. So meshing is done to divide the model into finite elements. Loads and constraints are applied. So the solver computes the stress, strain, deformation and temperature. So in earlier stages of design, we can compare with the existing one and reduce the existing problems. So now we are going to see about a prototype.
So in the prototype, the first step that we have to is the engineering data. So engineering data that, for example, so next step you want to import a geometry, or in the ANSYS software that we have option to draw a geometry itself. So the next step that we have to mesh the component. Meshing is done by dividing the models into finite elements.
So actually the simulation part comes before before you have to finalize a design which you have to do finite element analysis. So after doing a rough sketch of a design, you are supposed to put nodal pressures and pressures in specific areas that are required for sustaining certain strain. And we have to do it in simulations. There are simulation softwares like ANSYS, Inspire, and even in SolidWorks. And after doing this analysis test for 5 or 6 times, you will get a average value, and you can know if this current design is sustainable and can be used in regular purpose. If we can't do that, you can use topology optimization, which is a new technology that was developed in FEA, which can create support structures and effective layers to improve its strength and bending moments and FOS. And it's important to learn topology optimization.
Finally, we are going to stage 5, that is step 5, test, result, evaluation and validation. So why we using this design thinking?
So it helps you reduce the trial and the error in design. It saves time and cost. It encourages innovation through stimulation, which improve product safety and reliability. So I would like to conclude that design thinking transforms analyze FEA from a software skill into an engineering design making tool. By emphasizing with the problem, defining objects, ideation solution, prototype through simulations, and testing result, engineers can create optimized, safe and efficient design for the real world application. Thank you all.
Thanks.